Okay, hello class. This is our last lesson on permutations combinations. We're just going to be looking at some examples today. But the big thing is we need to know what kind of example we're dealing with. So we typically say there's four kinds of questions in this unit, and the password would be like a permutation. The birthday problem would be a similar like a permutation, but kind of using the slot method and the indirect method. A cards question would be any kind of like combination type question, and then the pizza question would be a combination question, but where you don't know the number of, you don't know what it's out of. So we're going to be watching out for those four today. So question here, are we dealing with permutations or combinations or both? Cards in your hand, password, lottery, committee, selecting sum to all of a pile of books, top five in a race. First one's combinations, then permutations. Combinations is the lottery. Certainly you could have lotteries or raffles where order matters. And so the key here is you're asking if the order does matter. So in a committee, it really could depend if there are roles. Combinations, where you're selecting sum to all of a pile of books. But if you think about like the order you're going to read them, then it could be permutation. Top five in a race, if you're ranking them or just taking the top five, it could be both. And then giving out prizes if those prizes are same or different. So like really what we're looking at is when do you use each, how are they related, and then like just solving complex problems with multiple cases, that third success criteria. So we're just going to look at a flow chart here to figure out how do you calculate probability for compound events. And so that's going to be like anything where compound events just means that multiple things are happening, like you're drawing five cards or you're taking a bunch of things. And so that's where we got compound events. You got a bunch of people, or you've got a bunch of toppings for the pizza, or you've got like different, like you got a bunch of characters for the password. That's what makes it compound rather than just like taking one person or taking like one letter password kind of thing. Determine n of s is like where I would start and just ask the question, does order matter? That's how we solve those questions on the warm-up. If it does, we're using permutation or the slot method. Slot method is the same thing. It's just one doesn't repeat every time. And if the ways do reduce by one each time, then it is a permutation. If not, then it's just the slot method. That's why you're always going to be okay just using the slot method as long as order matters. If it doesn't, then we're using combinations. And so then if you're not sure, you can also ask the question, are you assigning a certain number of ways to do each action? And so like, do you have slots? That's really the question. Each action of the compound event, or can you like just say, oh, like 52 choose 5. And so if you're assigning like 5 cards, and we've got to say this number for the first, this number for the second, then it's permutations or slot method. If not, it's combinations. Then you ask the question, are there multiple cases for choosing the small group from the larger? If not, if yes, then you're probably going to use some addition of NCRs or that pattern in Pascal's triangle. If not, you're just using NCR. So 52 choose 5 would be that. The pizza question here would represent that pattern of Pascal's triangle. You're not choosing exactly one topping. You're choosing anywhere from 1 to 8 toppings. So you can actually see the password question in like MPR or the slot method. But the birthday problem as well could be in these. The cards question would be here, and then the pizza question would be here. If you've calculated n of s, now to calculate n of a, you've got to ask yourself, how did you calculate n of s? Because you want to do it the same way. But if you did it by permutations, then you're probably going to use the slot method for n of a. They're just a little bit, like you don't have to say it's MPR, it's just using the slot method. If you use the slot method, then you use the slot method. You just ask the question, are there multiple cases? Because the indirect method could be quicker. And then combinations for n of s, then you're going to use combinations for n of a. But you're probably going to use the fundamental counting principle. And so that'll go back to like that cards question of 3 5s, the probability of 3 5s. And then always ask the question, are there multiple cases? Will the indirect method be quicker? If you use some of multiple NCRs for N of S, then you're going to use just the wanted cases for N of A, or you could use the indirect method.